So in this video, we want to talk about tangents and the relationships of segment lengths. So a tangent is nothing more than a line that passes by a circle and only touches at one point. So if I have this little line, not touching the circle, a tangent would be a line that goes through and touches the circle at only one point, just like that. So if I have two tangents that intersect outside of the circle, just like this, notice that at one end of the circle they're going to go away from each other forever, but at one point they intersect. If I look at the distances between their tangent points and that intersection point, they are congruent. So it's not to say that the segments or the lines or the rays, whatever they are, it's not to say that the whole distance is congruent. Just from this point of tangency to the intersection point, those are congruent distances. It's a very, very important theorem. And so if we have some application problems here, we can see that we have this circle and we have two lines that go by the circle and clearly don't go like that, and they intersect outside the circle. So because of that, those two tangents are congruent to each other. So I can say that 9x minus 3 is equal to 8x. I can subtract 9x from both sides, so I get negative 3 equals negative x. Divide by negative 1 to get x is equal to 3. I can check that by plugging it back in. 3 times 8 is 24. 3 times 9 is 27. Minus 3 is 24. So again, showing that both of these are congruent. Here I have this distance is 51x minus 1, and that distance is 50x. Because these are two tangents, the distance from the point of tangency to the intersection point of those two segments must be congruent. So 51x minus 1 equals 50x. If I subtract 50x from both sides, I get x, and if I add 1 to both sides, I get 1. 1 times 50 is 50. 1 times 51 is 51. Minus 1 is 50. Again, showing that these two segments are congruent. Now, we can use this and determine if a line is tangent or not. So here we have this line AB in both of these cases, and we want to find out if it's tangent. Remember from a previous section that a tangent to a circle is going to be perpendicular to the radius or the diameter. So what we have effectively is a nice little right triangle, or we should if this is a tangent. So we square the legs, so we get 5 squared plus 7.5 squared equals 12.5 squared. So that should be the case if this is a right triangle, and it should be the case if this line AB is a tangent. So what I can do is I can find that out using my calculator. So I can do 5 squared plus 7.5 squared, and I get 81.25. So that means that 12.5 must also be 81.25. But here I can see that it's not. So I get that 81.25 does not equal 156.25. So is this tangent? No, AB is not tangent. Now, we could also have, if we have this problem here, again, we want to find out the same thing. Here we have this supposed tangent line AB, and it makes this nice triangle, which, if we look at the tangent and the diameter, they should be perpendicular. So that means that 5 squared plus 8 squared is going to equal 10 squared. So without using a calculator, we can say that 25 plus 64 equals 100. And yet again, unfortunately, we have 89 does not equal 100. So again, no, this is not a tangent. It would be a tangent, again, if we get these two values to equal each other, because it would make a right triangle. A squared plus b squared equals c squared would work. That's the Pythagorean theorem. And so that's only going to work when this is a right angle, making AB a tangent. Another application type problem we could have is finding the perimeter. So here we want to find the perimeter of these quadrilaterals around the circle, but we don't have all the distances. Well, remember, these are really just all tangent segments. So here I have this segment, which is 11.5, but I don't have this measure. Well, notice they're both tangents that intersect, and we have this point of tangency. So then if this segment is 11.1, this must be 11.1. If this segment is 5.1, this segment must be 5.1. Now, if the whole segment here is 19.1, and this little sliver is 5.1, then this must be the difference of 14, making this 14. And if this whole segment is 25.1, then this segment here is going to be 25.1 minus 14, which is 11.1, making this 11.1 as well. Purely coincidental that these two parts of the tangent are the same length. So if we add these all up, we can have 11.1 plus 11.1 plus 11.1 plus 11.1 plus 5.1 plus 5.1 plus 14 plus 14. And I think that's it. So I should have 8 little segments to add up, which gives me 82.6. And that's the perimeter. Again, over here, we know that this distance is 13.1. So this distance must also be 13.1. Here, this is 14. So this must also be 14. And if this whole segment is 24.4, then if we subtract 14, we get this segment is 10.4, making this 10.4 as well. And if this whole segment is 21.8, and this segment is 14, then this segment must be the difference, which is 7.8. So this is also 7.8. So if we add up all of these together, then we will get the perimeter of 90.6. So, looking at this theorem of tangents, understand the pattern so that you have these little tangent segments that are going to be congruent to each other. Here, we can test if they make a right triangle. So, is it actually a tangent? And then, of course, the good old, hey, just solve for x by setting those two segments equal to each other.